Good morning, everyone. I am Grace, and I am a master's student from the Cognitive Engineering Lab under IMIE.
I'm Louis, and I'm an MN student in the EC department.
Hi, I'm Steven. I'm also a manager student from the EC department.
So our app, IntelliWork, is designed to help machinery operators in a chemical manufacturing plant. So as you can see from this picture, a chemical manufacturing plant contains a very large open space with lots of machines. Among this machine, a pump could break, a pipe could block. So there are lots of process disturbances that could cause potential loss in production. So it is very important to identify them and resolve them. So as operators, one of their most critical tasks is to check on the physical equipment to make sure everything is running okay during the unscheduled inspection. It is very important, but also very challenging because they have to attend to thousands of equipment at the same time. Currently, this process is not standardized, which means that it contains a high degree of variability, depends on individual. And it also known as hit or miss. So if you see something, you see it. If you missed it, there's nothing much you can do about it. Additionally, the operators are also experiencing a lack of an appropriate tool for information access and documentation. So both the management team and the operator think there's a need for an app to help them. And here's come IntelliWork. So the goal of IntelliWork is to assist machinery operators to inspect production process in a more systematic and efficient way. To demonstrate the functionality of this app, I will hand it off to Stefan and Louis, who will give you a demo.
So I'm an operator, and upon the launch of the app, I see that there are two main buttons. The Quick Start, which contains mapping functionality, and the Inspection Checklist, which contains a routine list of items to complete. So let's go with the Quick Start option. So I see that there are three tabs, and that the Map tab contains the floor plan of the building that I'm in, along with several dots. So the blue dot represents me, the operator, and my position, and the other dots are equipment. Green dots represent equipment that's close to me, and gray dots represent equipment that's far away from me. So let's proceed with the inspection. So notice that as I walk, the blue dot updates and tracks my position, and that the color of the equipment changes depending on the distance. So here I see that there's a pump, but yet for some reason it hasn't been added. So let's do that. So to do so, I'll hold on to the area of the pump's location, give it a name, as well as a type. And I add it and I see that it appears. So let's continue walking around. So here I see a tank, and if I want to look at the details, I go to the Equipment Info tab, and then I can click on the equipment to see its details. So from an operator perspective, I see that green values represent things that are okay, orange values represent things that might be worth checking on, and red values represent things that might be an issue. So let's take a look. Oh, I see, so at this point I need to fill out an incident. And to do so, I'll go to the Add Log tab, which contains a form to fill out details of an incident. I'll specify the equipment, as well as the title, a description, and the personnel to investigate. I'll take a photo for better detail. And after I click the Add button, I see a success message, which means that the incident has now been uploaded to a remote server. Sometime later, the team lead, Steven, will check his own phone, and he'll see the incident in his logbook.
So as a team lead, what I do is I always log over to the logbook module to see what incidents have been reported so far. So under the Unresolved tab, I see there's the incident with oil leak title. So I want to get more details. And from the picture, I can see the oil leak is pretty bad. That means I should fix it as soon as possible. So to find the equipment, I go back to the map module, and it does take some time to load the map. And as you can see, there's the tiny wrench on top of one of the equipment. That indicates to me is the one that needs to be fixed. So I go to this, and I see this incident, and I just fix the incident. So now I go back to the logbook and mark the incident as done. As you can see, now the incident is actually under the completed tab. So the last thing we wish to demo is that the checklist module, because operator list and I have done a lot of routine inspections so far, and we want to file a checklist which gives us a systematic way of filing a report. So I'm going to go ahead and fill in all the relevant information and click submit. Now this also goes back to the logbook module under the checklist tab. As you can see, it shows a list of checklists we've done so far. And this data is saved locally as well as to the remote database so that operators can use in the future to avoid doing any redundant work. So this concludes for our app demo, and now let's move to our software infrastructure. So the most important module we have is a free inspection route. It connects to the map analysis, which consists of 2 software libraries by which we use to retrieve relevant position information. And it connects to the add log module, which allows operators to file log incidents. And that data is being displayed in the logbook. And the last thing is a checklist. As I've mentioned earlier, it gives operators a very comprehensive way of filing their report. And all the data I've mentioned so far is being saved locally as well as to the remote server.
So key learning points. One thing that we learned is that it's very difficult to communicate to an audience about how your app is useful, as well as explain our app's functionality without using lots of technical terms. As for technical challenges, one thing that we would do differently is to more carefully design the database schema beforehand in order to avoid lots of code modifications upon any attribute changes.
So as a specialist, one important thing I learned is that it is really important to know what the end user is working on, and then therefore to create a concrete case that is meaningful and helpful to them. I also learned how to design effective user interface using online tools such as mockups. And most importantly, the communication is the key throughout the project. It is important to explain the technical jargon well to the programmers and also to get feedbacks and inputs from the operators.
So a few things we would like to do in the future. One of them is to have more checklist templates, and the other is to implement the functions to display up-to-date information, data sets of different types of equipment in terms of graphs, tables, and etc. This concludes our presentation, and now the floor is open to questions. Thank you very much.
Hey, nicely done. That's a well put together presentation. Lots of great stuff going on there. I just have a couple comments and then I'll open up to other questions. Just at the beginning, I think there's one word that needed more emphasis. You said really quickly. You said unscheduled. These are unscheduled inspections. But you kind of just went right by that, and that almost needs like a sentence that says that while there are regularly scheduled things, this is about servicing unscheduled things. You said it, but it just seemed one word. My only other question was, that wrench was sitting on a green dot that was in the middle, not on the left-hand side, right? Was that true? Did I miss that?
Yes, I think.
Okay. How did that happen? Because you did do the report over here.
I think we might have
I might have clicked on the wrong equipment.
Yeah,
because there were
associated with the equipment, with the wrench, he might have clicked the one.
That's the wrong one.
Yeah.
So.
That was quite nice, actually. Any comments, questions?
In the kind of chemical plants that you work in, does any of this equipment have any network connectivity for getting data out of, for instance, the chart you showed that said, here's the regular pressure of the pump.
Mm-hmm.
Does any of this equipment have any ability to access what the actual pressure is so that page can update?
Yes, there are sensors installed, but there are no Wi-Fi signal in the plant at the moment. So all the data is sent to the centralized control room where the operator can access. So within the plant, they can probably read it from a gauge, but that's it.
Okay, but in principle, if you implement this, you could integrate with that computer at the plant to get that data onto the operator.
Exactly. So now we're trying to pretty much put a control, like the monitor in the control room on a mobile device.
Is there an issue with getting Wi-Fi in these plants?
Well, they are working on that. I think they're using Beacon right now. Yeah, but I'm not.
Beacon for location, but just general Wi-Fi for data.
No, I don't think so. I don't think there's Wi-Fi right now.
Any other comments, questions? Yes?
Suggestion. Actually, you have so much technology, you're just limiting it to the chemical plants, you can release it to all of other things. I think you should do more things with it, like let's say, if you're in a building maintenance, so you can just say that something is not working here and the janitorial staff can come here and they do all of it. So this can be released as a framework for a lot of different things, just than chemical plant.
That's right.
Yep.
This relates to your research in some sense.
Yeah,
Is that right? How does it relate?
So my research is to introduce this concept called adaptive automation, which means that the phone like this one will sense the change in the surrounding, for example, like a change of user location, and therefore that will automatically trigger the change into the information content that presented to the user. Right? So that, like, for example, like I'm watching toward that tank. So only the information about this tank will show up, and all the other will be ignored. So that will help the user to have a reduced mental workload and to help them. So my goal is to decide when should this information show up and what information should show. And then I think this is a really great prototype for my thesis, and I'm actually planning to bring this forward into my experiment to actually test out some of the concept.
The underlying technology is pretty cool of mapping using magnetic fields. Is that technology freely available, or if you were to roll this out on a larger scale, you have to get some kind of permission or license from
Yeah, like you.
the rights holders if there are any?
So the underlying technology we're using is called Indoor Atlas. It's freely available for use, like you can freely develop with it with under 100 users. And then after that, I think you have to pay some sort of fee, licensing fee or some sort. Yeah.